Hello, everybody. My name is Amarachi Anacho. I am a developer advocate for Area, and today I will be talking to you about from monolithic to microservices with GitOps, migrating from a monolithic architecture to microservices with GitOps. So first things first, I just want to talk about monolithic applications for starters and the challenges with monolithic applications. Monolithic applications, as we all know, are software applications where all the parts of the application, the user interface, the backend logic, the database, everything is just combined in one single tightly connected system. So everything runs in one unit. One application is dependent, one service of the application is dependent on another service. And that can cause a lot of problems because even though that is simple and easy to manage, it can cause a lot of problems because one, it's so tightly coupled together. And because each service is so tightly coupled together, you have issues like scalability issues. If, for example, your application is getting really popular and you're getting more visits to the homepage and you need to scale that up, okay, you need more resources to scale that up. Instead of just scaling that the service that's responsible for the homepage, you have to scale the entire application, and this involves you scaling parts of the application that you might not have needed to scale, like for example, maybe user personas or the settings or different parts of the applications, simply because they are so tightly coupled together. And that can cause strain on your resources because you're spending more resources than you need to spend. Additionally, because they're so tightly coupled together, if one part of the system goes down, the rest of the application goes down with it. Instead of, okay, because they're so dependent on one another, if it's difficult, it's very inflexible. It's difficult to deploy if you want to deploy a bug fix or a new version of a service in your application. Sometimes you need to deploy the entire application. Why? Because it's so tightly coupled together. So when you listen to all these challenges with monolithic applications and you're like, oh, shouldn't you just break it down together? Which is a very popular solution, which everybody knows, which is microservices. You take that one singular application that used to be a singular unit that was so tightly coupled, and you start breaking them down into independent services, services that take care or cater to a single business domain. You can have maybe service for your if you have like an e-commerce website, you have a service that takes care of like processing payments, a service that takes care of like your recommending new things that you would like to buy or like to see. Have a new service that takes care of authentication. But this application that used to be one whole application is now divided into different independent services that caters to one domain. Now it's easier to scale because if more people are logging in, I need to scale like the whole authentication service. You can just scale that service instead of scaling the entirety of your application. It's faster to deploy. If you want to deploy a bug fix to the recommendation engine, you can just do that instead of taking the entire application down with you. It's resilient. It's easier to maintain because it's in small boxes, and each team can cater to their own personal small box. And you know what exactly is happening in that small box. It's independent. It's easier to test. And that is great. Okay, so now that you figured out, okay, microservices are what I should do. Microservices is my application is scaling. More people care about what I'm building. I need to move to microservice. How should I go about this? It's not just, okay, I have my application, let me break it down. It won't just work that way because one, you have to think about the design. You have to think, okay, if I'm breaking this down into several independent services, what are the business domains? What are these service truly independent? What will this service cater to? You have to model the domain. You also have to decompose the monolith because it's so intertwined with each other. It's so tightly coupled. You have services depending on another services calling functions in another service. You have all of them saving and collecting data from the same database. It becomes more when you start to take everything apart, you start to realize that it's a lot more complex than you think it was, because you don't want to end up with a distributed monolith. You don't want to have, okay, I have broken down my monolith into different microservices. But when you look deeper at it, you start to realize that even though these are different services, they're not entirely independent of each other, and they still require each other. They're still in some ways dependent on each other. You have your data management issues. Maybe you have a booking service, right? And you split up the booking flights from the booking hotels, but they used to read to the same database. They used to collect data from the same database. And you're now trying to create like singular databases for these different services. How can we make sure that, okay, there's data consistency? If we are tracking the data for flight booking and hotel bookings, how can we make sure that the flight booking is reflective of the hotel bookings, that data is consistent? How do we make sure that these services can communicate with each other? Because before they used to communicate with each other via function calls, but now you have to start thinking of API calls. Are there network protocols that you need to care about? You need to, because these services are supposed to be independent. Now you need to think about how to manage deployment and infrastructure, because before you could just deploy your monolith one and done, and you're done. But now you have different services that you need to consistently deploy to. And also, largely, you have to think about cultural shift. Oh, my entire organization did not used to think about building building software this way, but now they have to think about, okay, then we are different teams, and we have to cater to different services. How exactly do we go about it? And these are issues that would come up when you're trying to decouple your monolith. So how does GitOps help with that issue? First of all, what exactly is GitOps? From its name, you can hear Git operation. Git operations, or GitOps, is a paradigm that leverages Git, your Git repository, as a single source of truth to manage your entire software development cycle. So you specify how exactly you want your live environment to be. What servers, applications, how many replications of pods, network ports, and whatnot in one Git repository. And you have tools like Argo CD that ensure that, okay, what you've defined in that Git repository is what is happening in your live environment. So they make sure that whatever changes you push to your configuration repository is what is happening in your live environment. And that brings us to what are the core principles of GitOps. Like I said, it's declarative. One, that means whatever you declare in your Git repository is what exactly it is. You declare it as facts, not necessarily how you want. It's not, you don't declare it as instructions. You declare, okay, this is what I want, and your live environment, and you have these tools that ensure that your live environment is exactly what is stated in your repository, because it's using Git, and Git is as a version control tool. It's versioned. You have different versions of your configuration stored, so that, okay, I pushed a configuration that I am not with, I don't care about, or I don't like it. You can always go back and just roll it back, okay, to the previous configuration. If you were not doing that with GitOps, if you were just wrote your deployment scripts, use GitHub Actions, changed up your environment, if you wanted to go to like a previous state of your environment, you would have to start undoing some changes, and that could be a lot more complex. That could be more complex than you'd want it to be, especially if you've made a lot more changes. But with GitOps, you can simply reverse that Git commit, and which brings me to our third topic. It's pulled automatically. Once you've defined your environment in your Git repository, you don't need to start manually applying those changes to your live environment. That's not necessarily your job, and it's not even advised to do that. So you have tools like Argo CD that ensure that, okay, this is what you've defined, this is what you want your environments to be like. Let us make that happen for you. Also, if for whatever reason your environment drifts from your desired state of your environment that you stated in your Git. For example, maybe you manually changed some things that are happening in your live environment, or like your pods went down. These tools can just say, okay, this is not exactly what you defined. This is not what you wanted your environment to look like. Let's fix that up for you. And that's what GitOps is really amazing about. But looking at all these core principles, why should I care about that? How does that help me effectively migrate from a monolithic application to more microservice architecture? One, a single source of truth. Right, because you don't have your configuration scattered everywhere, scattered like in deployment scripts, scattered. You do not manually SSH into your environment and change some things up, because everything is happening in your Git. It's easier for you to understand what is happening. It's easier for you to collect your configuration into a repository and make that happen for your environment. Two, you can automate deployments. So instead of writing deployment scripts and running them, like running your pipelines, you can just specify how you want your live environment to look like in your repository, and it just happens for you. Like it just happens for you in your live environment. Additionally, you can gradually migrate some parts of your application small by small, because a lot of ways that we are advised to do to make big changes is just incrementally, small by small by small by small. You do not want to start like, oh, microservices is what I should do. Let me break apart my entire application, especially if users are still using the application. You're not going to tell them, okay, you can't access your account today because we are moving from a monolithic to a microservice application. I don't even think that a lot of users will understand what is happening. What they just understand is, I cannot access my account. So with GitOps, you can take apart some parts of the application. Okay, if you want to take apart the user authentication, you can do that. Create a new repository for that. Define your configurations in your YAML file, and recreate that section, that service of your application that used to be intertwined with your application. You can recreate that in a new repository and rewire traffic to that repository, to that microservice. And you can start taking it apart little by little and putting it in new repository, configuring them, and it's a lot easier for you to do. Fourthly, if, for example, okay, something goes wrong in your configuration, the way you've configured your environment, you can easily roll back to a previous configuration that you liked, or the configuration before, simply because Git is the single source of truth. Like Git is the one that Git is version control. So you can have clear separation of responsibilities. It's easier to collaborate with because it's Git, and GitOps tools integrate easily with a lot of observability tools, like you have Prometheus, you have Grafana, and it makes it easier for you to just understand what is going on in your architecture. Because one thing about microservices is that it's great to talk about, but it does come with its own complexities. It might be difficult to it's a lot more difficult than monolithic architectures to understand what exactly is happening, because now they're all separated and scattered, and might be scattered on different cloud platforms for redundancy and resilience. And while you're thinking about, okay, I want my application to be resilient, I want my application to scale easily, you start to introduce a level of complexity that you might not have bargained for. So observability just makes that a lot more easier to understand what exactly is going on and why is that happening. So like we usually say, maybe monitoring tells you, oh, there is a fire. Observability tells you where that fire started from, what else is it going to affect, and whatnot. And that can be great for your architectures. So now that you figured out, okay, GitOps is what I should care about. Okay, GitOps could really help me in this very stressful migration, not very stressful, but this migration. What are the best practices for using GitOps? What should you do? First of all, organize your repositories. I mean, if Git is going to be your singular source of truth, it makes sense to organize your repositories. You can have different repositories for your package, for your private package. You can have your private package repositories that could contain your Helm charts that everybody in the organization uses, so that you can make sure that everybody on the organization is working from the same page. And because that is something that everybody's going to use, you have to try to reduce write access to that, because you don't want, okay, we're using this version of NGX, we're using this version, then somebody comes later and makes changes to that, and you have some parts of the organization using a different version and some part of the organization using a different version. So you can have a package repository. You can have a repository that contains configurations for your clusters, your personal clusters. You can have configuration for your application environment. You can then now have you will now have a different repository that just contains your application code, because you do not want to mix your configurations with your code. That will stress you out. Secondly, use a centralized private package repository. Like I said before, if you have templates that the entire organizations are using, like your Helm charts and whatnot, you want to reduce write access to that as much as possible. You do not want anybody to just come in and work with it and tamper with it. You do not want that. Thirdly, write everything twice. And this might contrast the you do not repeat yourself principle that you kind of taught from very early on. But writing everything twice makes it easier for you to know what exactly is happening. So instead of creating a configuration file, then dynamically changing those configurations depending on your setup, you can now have a singular configuration file for each setup, so that you can just know what is happening. And it's just easier to debug. So you're like, okay, this is what I specified, but this is not what exactly is happening. And you can see that easily, because you are seeing, you're looking at the final configuration file. The configuration file does not need to undergo some sort of production or producing to get to the final stage. You can read what exactly is happening. Fourthly, you want to test your configurations early. I think testing, it's just a theme throughout life in general. So before you want to push those changes to your Git repository and let it affect your clusters, you want to be like, okay, is this correct? Is this what I want my live environment to look like? So you want to test those configurations early on. So also you can think of using folders instead of branches for your prod, your staging, your dev environment, because folders are easier to just read through and just look at what is happening. Like, you can use your tree command to say, okay, this is what these different configuration files differ from each other. Is this what I intended to do, or is this like an incomplete configuration? And it's just easier for you to look at with folders. But folders do have their own drawbacks, because one, with branches, it's easier to just merge a branch from, okay, oh, this is my configuration files in my dev branch. It's easier to just merge that to like prod and whatnot. But folders, you usually have to copy and paste this. Of course, of course, maybe there are different tools for that, but usually you have to copy and paste. Okay, this is working. But folders give you like a single pane of glass view of your configuration, so you know exactly what is happening. Lastly, you can pin package versions. You can specify, okay, this is the version that I'm using. This is Docker image that we are using, and you can pin that, so you don't have people using different package versions for their different environments, and have people struggling to recreate environments simply because they're using a different version than they usually would. So yeah, sorry. So what are the trends to watch out in the GitOps space? One, artificial intelligence and machine learning. I think that artificial intelligence has crept into almost every aspect of our lives. I was doing like a little research, and I was asking questions about what people, just generative AI in general, let alone classification AI. I saw that people are using artificial intelligence to write songs, to do a lot of things, and I was like, oh wow, people are artificial intelligence is everywhere. So it makes sense that you would see artificial intelligence in the GitOps space. So help you properly understand how to utilize or share resources. Also, with this new rise of like artificial intelligence in operations, AI ops, where you have people like ingest data, you create baselines and find out anomalies in those data and your metrics. That's something that would be very important in the GitHub space, especially the more complex your environment becomes, the more microservices you bring into your environment. Artificial intelligence and machine learning would be, invaluable in a couple more years or a couple more months actually. Then you have policy driven governance. So when you have a lot of policies that you need to cater to, you have the GDPR, the PCI. So you have to make sure that, okay, how easy it is, but how easy can I incorporate those policies into my own environment? So you start to have things like policy as code. So in terms of like when you say shift left, when you want to test your application as early as possible, you can now have that, but for policies, and make it a lot easier for applications to be aligned with the policies that they want to be aligned with, because a lot of these policies can get really expensive if you're not aligned with them. Like for example, the GDPR is about like 10 million, 20 million penalty euros, and yeah, so policies are something that people care about. So you start to see, okay, writing rules as code or policy as code, you have to care about enhanced observability. Observability has really, especially this year, I don't know if it's because I'm working in a more in an observability space. Observability has really been something that everybody's like, oh, we should pay attention to this. So you have the rise of AI ops, DevSecOps, which I'm going to talk about later on. You have more people caring about the community, joining the community to build more GitOps solution, to create more standards for GitOps solutions. So you have more community-driven innovation, and a lot of these spaces are really driven by community, what the community wants, people that use this solution, how exactly. So you have more community-driven innovation. You have DevSecOps, where you start to care about security, not start to care about security. When you have to put security into the code as early as possible. Then you also have serverless and functions as a service, where you have to streamline, automate creating functions, like you have the AWS Lambda functions and whatnot. So those are the things that we can see happening in the GitHub space. You can also see the GitHub space moving sort of like past the Kubernetes space, because I think there are a lot of the solutions that people are just saying, okay, there's more Kubernetes native and whatnot. And we are going to, I think in the coming years, we're going to see GitOps move past that, use more a lot in the technology space, in the software engineering space. So those are things that make GitOps really more exciting. And yeah, so this is my talk. This is how I think about GitOps. I think GitOps I don't think GitOps is a very new concept. It borrows a lot of ideas from like infrastructure as code and CI/CD. So it's just everything that you've learned a lot in in your DevOps career is just brought together to make it a lot more easier to deliver application, to deploy applications, to give your customers what they need as easy as possible and as quick as possible, and as efficient and as possible. So yes, this is my talk. if you'd like to find me, you can find me on LinkedIn at Amarachi Twitter. I also write about my findings on Dev.2. So yes, thank you so much for having me.